Rahul, you can go ahead.
All right. Um, Good evening, everyone. I'm Rahul Mangharam, and I'll be hosting this invited talk session. It's my great pleasure to have Pramod Badjate, who's the Group Vice President and General Manager at Arista Networks. He oversees the cognitive campus efforts. And so Pramod's going to give us a very interesting talk today on the evolution of enterprise wireless and looking at the opportunities and challenges as we see it overlap with 5G. And Pramod has been responsible for products, engineering, and businesses at Arista's cognitive campus portfolio. And he has over 2 decades of experience in wireless networking from CDOT to Bell Labs to Ruckus. And so with his over 2 decades of experience, he's going to talk to us about what's the road ahead. So welcome, Pramod, and we're very excited to hear your talk.
Thank you so much, Rahul, and hello, everyone. I'm really excited to be speaking to COMSNETS, and congratulations to the organizers. From what I've heard, it's been a very successful conference, despite the times that we are in. So thanks, Rahul, for that introduction. Yes, I have been involved, and I feel privileged to have been involved in wireless for over 2 decades. First time I got involved was with a startup, and then I worked with Cisco for a while, then with a company called Ruckus, and now Arista. It's been gratifying to see the explosion of Wi-Fi, if you will, where we went from sort of early adoption in enterprise to now what we see as most of the bulk of the enterprise traffic when it comes to IT goes over wireless, right? So what I'd like to do in this session is go down the memory lane and give you a little bit of perspective of how enterprise Wi-Fi evolved, what we went through, then talk about the challenges that we still hear from the perspective of an enterprise Wi-Fi vendor. What do we hear from our customers? What are the challenges that they still have? And then what are the opportunities we have to address some of those challenges, as a means of looking forward? And then very briefly, I'll also talk about 5G and wireless LAN, like, what's the implication to wireless LAN from 5G, because I get asked that question a lot. So let's jump into looking at how has Wi-Fi evolved, right? And you look at when I got involved in Wi-Fi during that startup that I talked about, it was the days of 802.11 AG. People were really excited that we were doing 10 plus megabits per second during that time. From that, we've come all the way now to 11AC Wave 1, Wave 2, 11AX, and soon Wi-Fi 7. And we've gone to almost 10 gigabits per second in terms of throughput. You can see during this time, the applications went from, just using it for basic connectivity email to now using for, large stadium events, AR, VR, all kinds of IoT devices connected. The number of devices per capita, just if you look at it over the last, I would say from 2010 onwards, went from about 1.8 devices per person to now expected to be 3.6 in 2023, about 10 devices per home, right? So by all accounts, Wi-Fi has been hugely successful during this time. And any of you involved with Wi-Fi or wireless, I think, we deserve a pat on our backs for, for the evolution that we have seen. I want to then talk about a little bit about what does this mean in terms of adoption of Wi-Fi, in terms of applications within the enterprise itself. Again, when I started, it was the beginning of Wi-Fi when it was being tried for basic connectivity. It was tried in conference rooms, perhaps for guest access initially. And then when security got addressed in Wi-Fi, it became used for productivity for employees. You had enterprise-wide mobility, but still restricted to corporate laptops. I think if some of you remember it, you couldn't just take a laptop and go and access Wi-Fi in a company, any laptop, right? Then was the dawn of the BYOD era, where you introduced mobile device management, more complicated policies on what you allow traffic on enterprise laptop versus laptop brought from home and stuff like that. And then there was a point at which Wi-Fi, I think it was 11AC Wave 1, started being trusted and became as fast as Ethernet, right? I think we are now, I think you'd all agree, what we would call as this era of all wireless office. I mean, gone are the days when you would go to office and then look for the Ethernet cable to plug into your laptop, right? In fact, many of the devices don't even have Ethernet interfaces right now. And I can't remember the last time, I remember days when I would take my laptop and I would make sure that I had an Ethernet cable before I traveled, right? I don't remember in the last 5 years why we haven't done that. And then it's not just laptops, right? You're seeing, not only smartphones, but lots of IoT devices. And the benefits in terms of productivity, infrastructure savings, just flexibility has been huge. Very few technologies that I can think of in enterprise which have had that type of productivity gains and benefits that Wi-Fi has brought about. So again, hugely successful in terms of adoption. And talking a bit about it from in terms of adoption of the various technologies that have come by, the various waves as we call it, all the way from the early days of 11N, you can see that successive waves. We went through wave 1, wave 2. We have Wi-Fi 6 and 6E going on right now, and Wi-Fi 7 to be coming soon. The one thing which I've seen is that these waves, have come faster as time has gone, right? From the time it took from 11N to get to wave 1 to the time it has taken to go to 6E from Wi-Fi 6 and Wi-Fi 7, it just seems like it's accelerating. But enterprises, the needs of enterprises have also evolved rapidly. And so the acceleration of the cycles in terms of adoption has also increased. You can see here, we went from roughly about 12 million devices shipped in enterprise APs. This is a report from 650 Group, to a forecast of we'll do almost more than twice that, right, in the next year or so. So again, hugely successful in terms of adoption. I want to talk a little about what does this mean in terms of how enterprises, IT departments have adopted Wi-Fi. What architectures have we evolved through during this time? Again, going down the memory lane, when I started, I was part of a startup which at that time, Wi-Fi in the enterprise was deployed as independent access points, if you will, right? They were not deployed as a system. Each access point, because it was deployed in limited areas, each access point was, an entity of its own. And as enterprises started deploying it more, a bunch of startups, including the one I was part of, came up with products which dealt with, multiple access points being deployed as a system. It was truly a large distributed system. You had something called a wireless LAN controller to which all the access points connected. That provided a unified control plane, unified management plane. The intent being IT would have, the deployment of hundreds of access points or thousands of access points would be centralized and simplified, right? From that, then, the CPUs on access points evolved and became much more powerful. So it became possible to come up with a controllerless architecture, with limited scale, but for small and medium enterprises, tens of access points, you could embed that controller functionality within the access points. So there was a dawn of the controllerless architecture, which was hugely successful in its own right in terms of number of shipped APs for small and medium businesses. And then some of the other technology curves that you saw was what was along with what happened in the industry. For instance, just like, applications, enterprise applications started moving to cloud because of all the benefits that cloud brings. There was the wireless management also moved to the cloud. So, we started seeing the adoption of cloud managed Wi-Fi or generally cloud managed networking sometime in, 2010 timeframe. Then with the advent of big data, Wi-Fi is unique in a sense that you can think of all the access points as sensors, right? They are collecting information on the devices that are connected to the network. You have information on location of devices. So a lot of this was intelligent, data that was needed to be, kept in a data lake and to be harnessed for a variety of applications, including troubleshooting. You could leverage it for security purposes. You could leverage it for marketing purposes, right? If you're a retail, and you could look at footfall analytics of where the users are, or where your clients are in the network. So you saw a lot of big data analytics type of applications being applied to Wi-Fi data. And most recently is the trend of now leveraging AI as its mainstream to leverage it for solving the problem of troubleshooting, figuring out what's happening in the network. So there's been a huge evolution of technologies and been applied successfully, for solving Wi-Fi problems. But in summary, we've gone during this time frame from coverage in small conference room to expectations of ubiquitous coverage and seamless roaming. Gone from small independent APs managed to large distributed, highly available networks. In terms of management paradigm, pulling SNMP log-based management to streaming interfaces into big data analytics, manual troubleshooting, looking at individual logs and systems to end-to-end using AI, ML, anomaly detection. Security evolved from, initial crude web-based security, which had a lot of holes, to now expectations are, you have zero trust, where, you expect every device is expected to be not secure, right? And the type of security technologies that have evolved with the Wi-Fi standard itself, with WPA3, and now You can see various other technologies have evolved to just take care of some of the concerns around security. And lastly, we've seen the evolution of on-prem controllers to increasingly being deployed using cloud management for all the reasons I talked about earlier, right? The benefits of cloud. And as you can see here, this is another forecast from the 650 group. It shows the enterprise Wi-Fi access points that are managed based on that controller device I talked about, as compared to cloud managed. And you can see that the trend is that while the on-prem controllers are here to stay, they're not going away, but they are in sort of slow decline as compared to the accelerated growth of cloud managed. That's where the growth is coming from. So the last thing I want to talk about in terms of trends, especially the most recent trend, is with the pandemic over the last couple of years. As we've seen increasingly enterprises are distributed. While it was already the case, it's just accelerated, where you expect bulk of your employees not to be accessing the network from within the premise, but being distributed. So the traditional notion of network perimeter and how you applied security mechanisms, while it was already changed, it's just become irrelevant right now. And so IT departments are also looking to extend the enterprise network into the home. The expectation is to provide the same sort of quality of experience, because the enterprise productivity depends on these employees being able to access network and have the same video quality of experience or applications. With the pandemic, you also seen Wi-Fi, because it knows the of employees, right? Applications like contact tracing, has been hugely beneficial on top of this. So that's another trend that we have seen. Now, that was sort of the history, how Wi-Fi evolved. So where are we today? What do we hear as an enterprise Wi-Fi vendor from our customers in terms of the challenges they face, and how they make their decisions about what they want to deploy? So first of all, Wi-Fi today is no longer nice to have, right? Gone are the days, which about 20 years back when I started, yeah, Wi-Fi is not working, I'll take my Ethernet cable and connect it into my laptop, right? Now, it's much more mission critical. It's got much greater business relevance. In fact, there's a statistic from Gartner which shows that, every minute of downtime of enterprise IT network, which essentially, if Wi-Fi is down, that's what it means these days, costs average large enterprise about $5,600 per minute in terms of lost productivity. Think of it, right? If you're a large retail, if you lose Wi-Fi, which essentially means you can't check out your employees. If you're a healthcare, it might even have life implications in terms of healthcare you're able to provide. So it's become much more business critical, which means that the IT department has to be on top of any downtime much more proactively than was expected before. During this time, we've also seen densification of the spectrum, right? A lot more devices that are there on the spectrum, which means it's more crowded. Wi-Fi is unlicensed at the end of the day. The type of devices that are connecting to the network has also increased. And that has its implications, because all it takes is one badly designed client, right, which doesn't adhere to the standards, and it has implications for everything. So you need to be able to monitor and troubleshoot new types of issues as a result of this. Security is paramount. I'm sure you all have heard about, all those famous cases of ransomware attacks that are on the rise. Data breaches are on the rise. There's one survey by a UK firm that showed that about 72% of major data breaches were ultimately tied down to an unsecured wireless device. It could be a printer, it could be a laptop which is unsecured connected to the network, right? So there is greater acknowledgement and recognition that Wi-Fi is very important to be secured, and there's a lot of complex policies and network admission control policies that are applied to Wi-Fi networks in large enterprises to address this. And all of this has meant that the complexity of network has increased. While the applications, and there are other things like I talked about that have come about to ease that pain, it's still not kept up. IT departments still face a challenge in terms of managing a network that is ever increasing in complexity and density. And so what this translates into, what we hear often from our customers in terms of the requirements that need to be solved when they are making a decision of deploying a Wi-Fi network or upgrading a Wi-Fi network. So I've boiled it down into two, and I'll give you the highlights from a network point of view, what the requirements are, and then from a network management point of view, what it means. From a network point of view, they want a network which is seamless, it's reliable. Reliability expectation is the same as what it used to be for a wired network. It needs to be seamless. You should be able to roam anywhere, without dropping your connection. Sufficient network capacity to deliver the same quality of experience on Wi-Fi as you had on wired. And ultimately, since Wi-Fi is a shared spectrum, you want to be able to have the capability to, the IT needs to have the capability to prioritize the users and applications that are accessing the network. You want to make sure that the onboarding of clients is frictionless, right? You don't want, if you're implementing policies and network access control, to people to have issues and then call IT and say, I can't get onto the network, right? It needs to be very low touch. And then security and being able to detect any security breaches and then being able to mitigate that proactively is very important. From a management point of view, it's all about ensuring that you're simplifying, you're easing that burden I talked about on IT, which means devices need to be zero touch, right? You need to plug it and they need to connect to the network and get provisioned automatically. Expectations on automation has increased. You need to be able to detect your environment and automatically provision your settings based on what the environment is. You have to obviously have end-to-end visibility. Management got out of the days when you would manage it piecemeal by looking at different parts of the system and checking into the logs, and all that needs to be end-to-end. And you leverage AI, ML to be able to detect what the network health is. And increasingly, as I'll talk about later, and in fact, I was talking to Rahul, you told me about, you're responsible for autonomous networking, right? The expectation is, to be able to automatically detect root cause and remediate when feasible, right? It's, the equivalent of self-healing networks or autonomous networking as we talk about. So, one other problem, in specific to Wi-Fi, as you all are aware, right? And this is the bane of my existence for the last 2 decades. You have often customers upset. No matter what happens, it's usually Wi-Fi which is blamed, because that's a first thing that employees are used to. And in fact, the reality is, according to some survey, while administrators spend half of their time chasing issues to Wi-Fi, roughly half the time the issues are actually not wireless, right? It could be client drivers, it could be the authentication backend systems which have an issue. You might have issues, latencies issues with DHCP, DNS, or a badly designed wired network. But regardless of what the issue is, it starts with being a Wi-Fi problem. So what we see as our mission, right, as Wi-Fi vendors, is how do you provide tools so that you can quickly figure out what the root cause is and and point the finger away from Wi-Fi, if you will, right, when problems happen. So how do you do that? And we don't have the time to go into the details, because this is obviously an area for a lot of research, but a lot of vendors are going down this route. Essentially, it's ripe for being leveraged by AI. You heard the term AI ops. Essentially, you're now taking the next step of saying, with all the data that you have from the network, you should be able to baseline the network and use techniques to determine the network health in a much more foolproof way, if you will, as compared to before. So you detect anomalies in the network proactively as they develop. You can then do root cause analysis and determine what's behind it, again, based on end-to-end analysis of what's happening in the network. You run it through a recommendation engine to figure out, what, if any, changes can result in mitigating those changes, those issues that you're developing, right? For instance, I'll give you an example. You might have applied a new configuration change to the network, right? If you can detect the health of the network, worsening, not just for the entire network, but it's important to localize it, like, to the smallest area. I applied a change, and this particular building, I see that the connectivity, the latency of connections has increased. I detect the anomaly, right? What can I do? Well, I see that this specific building is connected to this particular authentication server, which is taking a long time to respond. The corrective action might be I do a switch of the authentication server to a new one, right? So these type of things, not only do you detect what the issues are, but you can take corrective actions by forcing that. And hopefully you have an era where some of these common issues which IT needs to run around and figure out what the issues are and take the corrective action, they get a report in the morning saying, hey, we saw this issue, we took this action, and we can show you now the KPIs that the network is back to normal, right? That's what we're aiming for in terms of what we call as a self-healing network. So I want to just leave you guys with some sense of, from an enterprise point of view, what we believe are key research opportunities, fertile opportunities that, and I know a lot of academia is involved here in this conference. Obviously, self-healing and autonomous networking is a topic on its own. Determining network health is not an issue, not an easy thing to solve, because networks, even in wireless, right? The KPIs that you see to what a network means is very different for a warehouse as compared to a carpeted enterprise, right? Or In Manhattan, you might be in a building with a lot of noise pollution, with surrounding neighbors having Wi-Fi versus in a rural area where you have the spectrum to yourself, right? So you have to be able to baseline in the context of the environment you're in. Root cause analysis, needs to become more precise, because network management, as you all can appreciate, right? If you have too many false positives, then people give up on it. People stop looking on it. So how do you make sure that it is meaningful, actionable? And then the whole notion of recommendations engine. How do you learn based on internal expertise, based on other customers, what configurations result in what kind of reaction in the network, right? And build that knowledge graph that then it can be used to apply for remediation when issues do develop. The second area, which I think is very interesting in developing, is just the efficient leverage of spectrum and the radio resources in a multi-radio environment. Because we've gone on the Wi-Fi side alone from 2.4 gig and 5 gig to now with the advent of 6 to 6 gigahertz radios, right? The standards have developed where we now have, with Wi-Fi 7, we'll have multi-link operations. We have things like preamble puncturing coming in Wi-Fi 7. And then with the dawn of 5G, it will get deployed in some areas of the network. You will have the coexistence of Wi-Fi and 5G. So you can imagine that the evolution of the network, all of these will need to coexist. And there is the opportunity from a technology point of view to abstract all of this and optimize the leverage of how you schedule, what users and applications are going on what radio resources, so that overall you're optimizing the experience of the end users, but also optimizing all of these resources across various spectrum or frequencies, if you will. And then lastly is real-time location services. When I started, my with the first Wi-Fi company, at that time there was a promise of real-time. In fact, we were amongst the first ones to build a Wi-Fi-based location services engine. But I think it's not lived up to its promise because of the challenges that exist with Wi-Fi and location. It's remained niche, if you will. We've also had MAC randomization, so now it's difficult to have applications which are based on tracking individual clients. So how do you adapt that, and how do you make sure that you can still do footfall analytics, if you will, right, and get still the same benefits that Wi-Fi can provide because of some of these things like MAC randomization? How do you leverage newer technologies with angle of arrival, time of flight, and other things to maybe realize the promise that we had with indoor location? There's also research going on with occupancy monitoring, right? With Wi-Fi, you can look at Wi-Fi waves, sense the waves bouncing off of people, and I've seen some initial research which shows you can detect the number of people in a conference room. You can even detect how many people are breathing, and all of that, right? So there are very interesting implications and applications based on these areas. So moving on, I want to quickly talk about one of the areas I talked about is densification of Wi-Fi and the crowding of spectrum, right? Well, the good news is, and we are very excited on the enterprise side with this, with 6E, for the first time in a long time, we will have for Wi-Fi a whole new spectrum, about 1200 megahertz, more than 2.4 and 5 gig combined, available. It's already available in US, and we expect it will follow in the Europe soon. We're particularly excited about it for various reasons. One, it's obviously a large spectrum, allows wider channels, so it obviously helps with throughput and all of that. But because it's a new spectrum, you also have less interference. Because it's a new spectrum, it won't have the baggage of legacy devices, right? What happens with all the other evolutions we've had so far, because you have to support older devices, that sort of drags down the rest of the network in terms of spectral efficiency. You don't have that issue with 6 gigahertz. And then on top of that, you also have better security because, again, you don't have to support the legacy mode. So I think this is a good inflection point between Wi-Fi 6E and 7. We will see, I expect, an adoption of the 6 gigahertz spectrum very rapidly by enterprises. And then Wi-Fi 7 is coming soon. In case of Wi-Fi 7, we are shifting back to focus on greater speeds and feeds with 4096 QAM, 16 by 16 MIMO, wider channels, 320. So you'll see greater throughputs. I think the focus of this will be around apart from throughput, low latency applications. So a lot of AR, VR applications in the enterprise will start to get enabled on top of Wi-Fi 7. I will quickly talk about in my last slide about Wi-Fi and 5G, because this is a question I get a lot, that with 5G coming in, is that going to somehow supplant Wi-Fi, if you will? And the reality is, I think Wi-Fi is here to stay, right? It's unlicensed, it's very low cost, it's very ubiquitously available across a wide variety of client ecosystems. So Wi-Fi will remain the technology of choice in enterprise. And in fact, some of the concerns around unlicensed and spectrum densification, if you will, is eased by Wi-Fi 6E, what I just talked about. So we believe that Wi-Fi will remain the technology of choice, but 5G may have areas. There are areas where reliability and reach, because it's especially at 3.5 gig, if you're doing unlicensed, you have a longer reach, at a greater range in outdoor manufacturing, those type of applications. You might see coexistence of both of them. I in fact think that there will be interesting evolutions of the architecture of enterprise wireless, where you'll have Wi-Fi and 5G coexisting and making it seamless. And with the help of client vendors, it shouldn't really matter what radio your traffic is going on. In fact, you might want to prioritize your traffic and say this type of traffic goes over 5G if it's available, and this type of traffic goes over Wi-Fi, right? But from a management point of view, it should sort of seem seamless to an enterprise IT deployment. So I believe it's really going to be 5G and Wi-Fi, and not a question of 5G or Wi-Fi when it comes to deployments and choices. So I think that is what I had the time to focus on. I will pause here and I'll take any questions that you all might have, if we have any time for questions. Thank you.
Thank you, Pramod. Yeah, we can take some questions from the audience.
Thanks, Pramod. This is Amit. I'll ask does anyone want to ask a question? Okay, we have one question, and that will be the last question because we are running out of time.
So since we are talking about using 6E standard, so do we have an understanding of what proportion of users use the 5 gigahertz band? Because I still see that most Wi-Fi routers tend to use the 2.4 gigahertz as the default one.
Yeah. Well, I don't know about default, but by default, 2.4 and 5 gig both are turned on. Yes. In fact, we've struggled with this on the enterprise of, do we need 2.4 anymore? The reality is that there are a lot of devices, especially IoT devices, still that use 2.4. But I think predominantly, and you'll see that, with applications like band steering and others, many enterprises do turn on, forcing users to come on 5 gig as compared to 2.4. And some applications, they turn off 2.4 radio in some areas, right? So majority of enterprise, traffic does go on 5 gig these days, but 2.4 is also ubiquitously deployed because of, devices that still need that support. But if, I don't know the exact percentage, but I would be surprised if, I wouldn't be surprised if 80-90% of the traffic, in a typical enterprise deployment goes over 5 gig.
Thank you, Pramod. And as a token of our card, so if you can display it. Is that visible now? Okay. Yeah. So that's about it. And help yourself to something from Amazon. And Rahul, if you would like to close it up.
Yes. Thanks, Pramod. That was a great talk. I think you also covered a lot of interesting questions about, what kind of research topics some of the budding PhD students could look at in terms of this autonomous or data mining of, the traffic on the network for self-healing. Thank you very much.
Thank you. Bye.